Well, hello there and welcome back. Well, so I have been interested in the abacus, the Japanese abacus, for a long time, since I was a kid, actually. There was a point in time where I decided, well, maybe I could make my own abacus, really for no other reason than it's just fun to kind of make stuff. And I think the first one I made was a 9-bead abacus. These were using these black and white little craft beads, and I was interested in this configuration of 9 beads with alternating colors. And these used these faceted biconic shaped craft beads that in some ways kind of resemble the Japanese soroban beads in shape, although not exactly. But besides the 9-bead abacus, though, I did make a number of more conventional soroban style abacuses, the 1-4 configuration. This one is using pre-manufactured round wooden beads or wooden balls with holes already drilled in them. This also uses those faceted biconic plastic craft beads. And these abacuses were sort of like as much experiments in making wooden frames as they were anything else, because I didn't have access to the ability to make my own beads, at least ones that would look good and look uniform like the actual Japanese abacuses. And also, it raises the other question, why would you even want to make your own abacus if you can buy a $20 approximately abacus like this on Amazon that has an automatic clearing mechanism, you know? So, I don't know, I like making things. Well, of course, there is this idea of the maker movement that's been around for quite a while now, and when I got into 3D printing, one of the first things I thought about was, hey, why can't you 3D print some abacus beads? So I want to talk about that today, and also expanding on the idea of just making abacus beads. How about making an entire abacus with a 3D printer? Well, the traditional Japanese soroban abacus beads are these kind of biconic shaped with a sharp ridge in the middle that are really very efficient to move because you can easily grab each bead individually because of the ridge on it. And I tried to reproduce that with an initial design of a 3D printed biconic bead, and this is one example. And of course, because it's printed with thermoplastic filament, it has this funky texture to it. It's rather uneven. You can see irregularities in the shape of it. And also, the way the printing works is it does it layer by layer from the bottom up. And so when you have this kind of a profile where the bottom of the part is smaller than the rest of it, it doesn't print even all the time. There's only a certain angle that you can print this at. So the result was these irregular shaped beads. I did them in several different sizes. So not very satisfying. I mean, I could have made a bunch of these, but they just don't look very nice. Well, when I was showing my friend Ethan my abacus collection, he noticed this large Russian abacus, and it has these very interesting shaped beads. They also have a central ridge, but they're kind of like more curvy the way they come out, and he really liked the shape of those. So he helped me to design a kind of bead that was inspired somewhat by that shape. And again, these are 3D printed. You know, they have this rough texture and they don't always print very well because it has to print on the small base and get built up and then cantilever out as it gets built up. So they're not always very uniform or smooth. This was what I consider to be like a failed experiment in 3D printing abacus beads. In fact, all of them that I've made so far up to this point were kind of failed experiments. They just weren't shaped as uniformly and as nicely as I would like. And so one day I sat down with my handy desk and started to sketch some thoughts about abacus beads. And what makes the classic Japanese abacus bead work so well is it has this central ridge with the sloping biconic sides which support the hole or the tube through which it rides on the rod. And so I decided that I could minimize the whole design of this by making a hole with a ridge on it, or like a disc with a hole in it and a tube attached to it. And I originally thought that maybe I could make these out of metal, like brass or something, and you could solder them together, which would be very labor-intensive and fiddly. But thankfully, my friend Ethan had some spare acrylic, plastic, and some time on his laser cutter. And we made some of these beads in that general style, a thin disc supported by a small tube on either side. This is sort of the minimalist Japanese abacus bead, or what is essential to the abacus bead in design. So these were made of little small discs of acrylic plastic that were solvent welded together onto the bigger one. And these actually work quite well. They move nicely. They have more density to them. They're heavier than the filament 3D printed beads, but there's only one problem. These are intrinsically uneconomical to make in large volume because it takes a lot of laser time, first of all. Secondly, it's relatively easy to get a 3D printer these days, but to get a laser that can cut 3 or 4 millimeter acrylic plastic is a much more expensive, larger machine. And so it's just not practical at this point, I think, for the hobbyist to make laser cut plastic parts. So despite how nice these were in operation and weight and everything, I had to come up with another idea that would be more compatible with 3D printing with filament. I took the idea of the rod and disc design and moved the disc out to one end so that you could 3D print this on the flat surface that disc presents. That could be the bottom of the part. It could print on the bed easier. And I think it would still operate very similar to the way a traditional bead works. And so these were some general layouts that I was drawing about how you could use these T-shaped beads, the 4 on the bottom and the 1 on top. And it looked pretty good as an idea. It looked like it was workable. And then one day I was sketching on a napkin and I come up with the idea that, well, you could sort of make a variation on that design, but make it a single cone, a half biconic. And so I sat down and 3D printed this conic shaped abacus bead. But this was kind of the breakthrough design that I thought would really work well. So finally, I hit upon this shape, similar to that conic one, but it's curved a little bit more on the sides. So these beads I made are 22 millimeters in diameter along the base of it. So that gave me the dimensions that I could use for dimensioning the actual frame of the abacus. So there was quite a decision I had to make regarding how big the beads would be. I wanted this abacus to be usable for adult-sized fingers, adult-sized hands. And I knew some of the exquisitely made Japanese soroban abacuses are a little bit too small. The beads are more for children, school-age children. Also, the PLA plastic is not that dense compared to the hardwoods that they use for these handcrafted abacuses. So making the beads a little bit bigger in diameter means they're going to be more massive. They'll have a little bit more weight to them. It'll work better. So this is how I came upon hitting upon the idea of these 22 millimeters approximately as a good size, almost an inch. Here's a couple extra beads. You can see how they work. And your finger can easily get between them to move them either direction. And yet, being only conic instead of biconic, they can be easily 3D printed on the big round base of the bead, so they can be more uniformly shaped. And you don't have the problem of trying to print them upside down with a small size base. They just print more uniformly. And so I started designing one that would have 5 rods. Not a super large abacus, but it would be a usable abacus. And I started laying out dimensions and figuring out how big it is based on the beads I had made. So this frame that I designed is going to be 10 millimeters thick, each top, bottom, and sides. The dividing bar will be 5 millimeters thick. I have the spacing of the beads figured out from this little diagram right here of all 5 rods and how much room there is between each bead. And so this is what I based my CAD design upon, this sketch. It has these little finger joint on the 4 corners, how they interlock. That's how they're going to stick together. And so I started designing it in CAD. So I went to the hardware store and I bought a 3-foot or 36-inch long piece of this tubing. It's nominally about 1/8 of an inch in diameter, outside diameter, which is 3.18 millimeters. And the holes I've printed in these beads are nominally about 4 millimeters. Has a nice fit and moves very smoothly. So this 36-inch long piece is enough for me to make all 5 rods for this 5-rod abacus. It feels like the rods go in the holes very smoothly. This is the first time I've actually test fit them, and yeah, that's really nice. Nice and flush there. Got to cut some tubing, and I have to print some more red beads. Okay, so here's a good test to see if your beads are moving good. They should be able to slide on the brass rod on their own, just like that, just by their own weight. And here is the prototype. So it has top, bottom, side pieces all linked together using these finger joints. And by the way, I have not yet applied any solvent welding solution or glue. These frame members are just simply stuck together, and it holds itself fairly tight, actually. And you might be able to see here, if I get some proper light on it, that the dividing bar has a little finger that sticks through the side pieces, and that's how it stays in place. So when I printed these initial frame members, unfortunately the dividing bar, you may not be able to see it, but the dividing bar didn't print right on one part of it back here, and so I figured I was going to have to reprint the dividing bar just to have a nicely printed prototype. And then I started thinking, well, if I have to reprint the dividing bar, maybe I can make it a different color. I think the black and red is a nice design choice with the brass tubes, but I decided, hey, let's do blue. So I'm going to take this apart and I'm going to install the blue dividing bar in place of the black one. These brass tubes are 5 inches long, and they just press into the upper and lower frame members. And eventually, when this is permanently made, I will flare the ends slightly and they'll go in the hole very tightly, and you can also glue them in if you wish. But I'm going to pull all of these out so we can take the frame apart and replace the middle dividing bar. Okay, so now the trick is going to be pulling off the top and bottom pieces. They are not glued, but they are a little snug. There we go. Okay, there we go. By the way, I have to trim the flashing off of it. I didn't trim it after it was printed. So you might find there is a little bit of an elephant's foot, kind of a widening at the bottom of the printed part because of the way it sits on the base, the platen of the printer. So I just had to trim that a little bit out. So the bottom part that is resting against the platen of the printer is the one that gets really smooth, and I'm going to choose to orient the dividing bar so that smooth side is facing to the operator. So here we go. This just fits in there, and this one fits in there, and now we get the top and bottom pieces fitted like that, and like this. So this makes it a lot easier to assemble the abacus frame when you have the holes for the rods going all the way through the top and bottom. It just makes it so much easier. Let's get started here. The bottom 4 beads have their small ends pointing up. And then the upper bead is pointing the opposite direction. This is how I figured it would work best. So you seat it so it's nice and flush on both ends, and proceed with the other rods. Well, okay, there it is. I think it's a nice looking abacus, really. It looks like the beads move smoothly. So I'm going to have to test it out here and see how I like it. Well, I like the way this project progressed, starting with just a sketch done in mechanical pencil on my handy desk, through a series of more sketches, more thinking about what is the essence of an abacus bead, the ridge, the little tube that it rides on the rod. How can we best print that with 3D printing? What is the weakness of 3D printing from the previous examples I've tried to make of 3D printed beads to this conic orientation of bead that seems to operate just as well as a traditional biconic shape, but is much easier to print more uniformly. I might make a bigger one with a few extra rods, like maybe 8 rods instead of 5. That would probably satisfy most everybody's addition and subtraction needs. Now, this particular prototype, of course, I have not welded the corners yet. Weldon is a acrylic plastic solvent welding solution, and my friend Ethan uses it oftentimes. He uses it in a tiny little syringe with a needle type syringe, and you can get it into the little cracks in the joints and weld together the frame. I'll be doing that eventually, but the dimensions that I made this prototype at were close enough that once you trim the extra flashing off the part from printing, it fits together quite nicely without welding. Of course, you will want to eventually make sure it doesn't fall apart. But anyways, I really like the design as it came out. I do like my choice of colors. I think that blue dividing bar does add a little bit of extra snazz to it. In any event, I'll leave the files down below. I'd love to hear your comments about this project. And as always, stay creative and have yourselves a great day. Bye-bye for now.